I'm going to give a short talk on PostGIS, which is the geographic extension to Postgres that is somewhat famous. Even if you don't use it, you've probably heard of it. And I guess it's an answer, in a way, to Oracle's spatial extension. It's really the only geographic thing that I'm that familiar with. I know how to use shapefiles in ESRI, and I know how to use PostGIS, so I can't really speak to how it compares to other things. And I'm just going to give a quick run through on how you might use it, and presentation overview. I'm going to give a quick run through on how you might use it. I'm not a hacker on it. I'm just a user person. So, I use it to process data. I won't be able to talk about the internals whatsoever. And that's it. And we'll do that for 40 minutes, and hopefully you'll all be excited, and that'll be that. I do have a question, and that is, how many people have done geographic modeling? If you can raise your hands.
Oh.
Cool. Cool. Okay, I'm going to go ahead. I have a section in here which is the Cook's tour of geographic modeling for database people that haven't ever done geographic modeling. I'm going to go through that and go through it kind of quick if I can. Then I'm going to talk a little bit about the structure of a Postgres table, because it doesn't take over the database in any way, which is one of the many nice things about it. I'll talk about a table and some of the infrastructure for it. Do a few slides on installing it, which is trivial, but whatever. Then I'll allude to some of the functions, data types, etc. I won't go into the detail on them. The docs are great. So if you have an overview, the docs are really easy to deal with. So I'll give you that overview. We'll do an extended example. It's running now, and I've got data in there that's projected, so we can actually do queries if we have time, if there are specific questions. And my closing thoughts will be basically a pointer into the direction of geographic data, which is like the tip of the iceberg would be an understatement for what I'm going to do. I'm going to do a little quick thing. We're going to overlay some stuff, and oh, isn't that neat? But this is a massive, massive field, even logically, and not even in implementation, it's even more massive.
You'll have links to resources at the end, right?
Yeah, and I have links to resources sprinkled throughout. I will hand Selena a CD when I leave here. Hopefully that will make it.
It will make it onto the PostgreSQL Conference website, all the talks.
Yeah. So, and there's more stuff. Oh, and then in that CD, I'll also tell you this. I'm going to use Map Server to generate a few really bad maps to illustrate my points. And like all that code will be on the same directory. So it's a short little intro to GIS, but there it is. When do I have till? When do I have till? 2:30?
Something like that.
I actually think I'll go on here.
Looks like 3:15 data starts.
Wow.
You got now.
That's funny. So who am I? I'm a fourth year PhD student in demography at UC Berkeley, the home of Postgres. Yeah, I haven't met Stonebreaker, but
He's in MIT now.
He's where?
He's in MIT.
I was going to go back and being at Google, but so I'm not a computer science guy. My field is counting people. I have anthropology, cultural influences, kind of interest in that, and the synthesis of, I would like to find some way to synthesize big data, i.e. demographic data, with cultural stuff, whatever that is. I'm doing field research in Oregon in a small town, which hopefully you won't be able to discover from my examples. But if you do, it's not the end of the world. But I've been using Postgres for about 7 years. I code in Python when I code. And I'm currently employed half-time through the university as a scientific programmer for one of our professors doing mortality forecasting. Or web-based mortality forecasting. So if you want a link and you find a mortality forecast, you've got a big set of death rates, and you want to put it into a form and get a mortality forecast,
So you're the owner of the Am I Dead or Not survey?
Are you going to be dead soon survey is the one that we
Well, I don't want to interrupt your talk, but people have already started to smell it. So the coffee's here. If you want to take a break now, you can start.
I would personally love a cup of coffee.
Okay, let's take 10 and give Webb a cup of coffee. So you can thank these two over here.
Thank you.
You're welcome.
Let me.
At each other. So I have.
That's a nice walking through.
So that's who I am, and
He's the coffee Jones? No. Webb's.
no, but I do have. Who needs water? You know. And if you've got questions or whatever, just raise your hand. So acknowledgements. Selena and I talked about this. First of all, the people that make Postgres happen. I don't make Postgres happen. I just use it. Refractions. Who built PostGIS and made it open source and supported it. Selena and PDX Pug. All my data for this example and from my having learned PostGIS are from the Oregon Spatial Data Warehouse, I think it is. That's the link. And it's all been projected to the same projection algorithm, something or another, so you can, it's easy to get started with it. Portland State and our Portland sponsors, by which I mean Java. Everybody else. So geography concepts. And I'm going to run through this kind of quick, but if you have questions, slow me up. And if you don't have questions, I'll just run through. So modeling for database developers and administrators. The important thing to remember is that we were just going to model geography using the same, using very different basic concepts, but you know, we model everything, so we're going to model geography too. And before we start, I'd like to make the important point to me, as a bad visual artist, that cartography is a completely different thing than geographic data. Cartography is awesome. I don't do it very well. But it's awesome. I don't want to denigrate it. But presentation does not equal storage or logical information. Geographic information can be presented as raw numbers in tables and is interesting in its own right. Cancel rates by proximity to a toxic, for example, which would just be a list of rates and a list of distance or what have you. List of sales leads by zip code, whatever. That doesn't need a map to be geographic and important or useful. Cartography, different art, and like I say, you'll see a lot of really bad cartography in the following presentation. So, and I'll keep it to a minimum. I'll try to mostly do words, but there you go. So, there are two basic types of geographic models. There are vectors and there are rasters. And a vector is a single arbitrary shape. That's a set of vertices that are connected. There are multi-vectors, which we will not talk about again, but that could be a collection of these vectors in a single geometry object thing. And vectors are, once we kind of do both of these for 2 more slides, vectors are all we're going to talk about today. They're easier to model. They're easier to model with for most things that I do anyway. Other thing is very important, but that's all we're going to cover. So rasters, the other big model, is basically they are a homogeneous grid of cells, like your TV screen. Each cell has a vector of information, so each pixel basically has a set of numbers that go with it, and each pixel has the same data type as every other pixel, and corresponds to, in the geographic model, each pixel corresponds to a patch of ground. And one pixel equals a meter, or one pixel equals an inch, or what have you. These are hugely important. And if you do the physical sciences, they're maybe dominating. If you do the social sciences like I do, vectors are probably more important. There are others, DEMs, which are digital elevation maps, PINs, which are triangulated something, which is basically modeling a topography using triangle vectors to do it. They're there, they're cool. That's all I'm gonna say about them. Here's pictures of our two main geographic models. So there's a vector. It's not a mathematical vector at all. I mean, it's vaguely related, but it's not. There's a vertex, there's a vertex, there's a vertex, etc. They have an orientation. Generally, I think it's counterclockwise. I don't pay much attention. It has an interior, an exterior, and a boundary edge. They can be messed up, so you might have like double vertices or something in your data. You know, they might be oriented the wrong way or something. So they can be messed up, but that's a good one. Then that's a raster, which is, like I say, just a grid. Each cell has a value, or a set of values, and each cell is homogeneous.
When you say messed up, do you mean wrong, or messed up as in it can just be a really tweaked vector?
Oh, as in wrong. As in back, like you can take a bunch of vertices and make a geometry object in shape files and then those GIS geometry objects and have it not be representable or usable, even though you've stuffed in something that is formally correct. You know, you've stuffed in. So like in a list of points, you might have double or triple vertices. I think in some data representations, they have the orientation of the polygon, and that can get screwy. I don't actually know much about it.
I could say some ugly pots of
Yeah, yeah, and then when you try to join them or try to do overlaps, it gets messed up. But it can also be unbelievably tweaked, which is something else. You have a polygon of a county, you have a lot of vertices, you know, and it's messy, and there are holes in the side.
Does it need to be a simple closed curve, or?
You know, you're pushing the boundaries of my theoretical knowledge at this point. So you can definitely have an interior as part of the same thing. And if anybody is an expert, and that's quite possible at PDX, they should chime in.
I think if it's not closed, then it's defined. Like it's a different type of object.
But if you think it's closed, or you think it should be closed, if you think it's a polygon, then it's a polygon. It's just a messed up polygon, because you're going to treat it in your operations as a polygon. So you're going to think it has area, even though it's not closed. And it can have interiors. I honestly don't know if it's a multi-polygon that has an interior.
It's a regular polygon.
Wait, it's a regular polygon?
So the regular polygon has an exterior ring and any number of interior rings, which are supposed to describe holes.
And their orientation is different, right? Like the outside is supposed to go one way.
I'm not sure about that.
Generally, in most of the GIS systems, as opposed to the theoretical mathematical systems, the vectors actually go the wrong direction. They go clockwise instead of counterclockwise, except in the islands. And to designate an island, they go the other direction.
Yeah. Okay. Yeah, and I don't know why.
Not that it really matters.
But well, the orientation, I mean, it's a nice trick.
For the purpose of this talk.
Yeah, and honestly, like I've done a bunch of within queries and overlap queries, and it doesn't come up. It doesn't have to come up. I think it can, especially if you're creating, you'll see where, like, if you start to create your own data point by point, you could go wrong in a way you won't go wrong if you just download it off State of Oregon website.
Yeah, actually, I've written software to create topologies, and if your software is correct, you don't have to worry about any of that.
Yeah. So all the data you will see, somebody else worried about it for me. And then you can have islands in the middle, and I think that the orientation is generally used as a hook for how you describe that. So if you've got, just pretend that this is how it goes, even though it probably doesn't. Then if your arrows are pointing in the other direction, then you know that it's an interior. And if you have a ring in there, because of its orientation, you could figure out that that point in the middle of that imaginary ring doesn't belong to the polygon. So in a query where you're saying, is this point within this polygon, you'd see that it was in the middle of that empty space, and you'd say, no. can we? And so that's a raster. I'm not going to talk about it again, except to say that when you collect large-scale data off the United States in a flyover with aerial photography or with elevation stuff or with satellites, that's what you collect.
Raster sure seems easy.
It depends. They're easier to get raster data and harder to manipulate raster data because you don't have any sense of topology with that. You just have, if it were topography, you'd have 50 meters, you know, and then another pixel that you wouldn't have any slope. It's just a discrete jump. So you go from 50 to 40 to 40 to 40 to 50 to 50, and you know, there's software to figure out what your features are and create vectors out of them. But
those data sets are huge too.
Yes.
yeah, and remote sensing data sets are on the, like, they start at gigs and then they're massive. Yeah, generally vectors are a lot smaller. And vectors correspond to regions, you know, and rasters correspond to just raw stuff. Okay, vector types by dimension, points, lines, and polygons. All your models are basically going to either have a point, it's just a zero-dimension thing out there, like a city on a big map. You just say it's there. You know, there is no sense of being in of it or out of it or on the side of it. It's there. Lines have only one dimension, like she was saying. It doesn't close. And points are used, like I say, for cities or for there's all sorts of point data. Lines used to model roads and rivers are the kind of nautical examples. Then polygons are 2 dimensions and regions in your space. Maybe very next year or whatever. I'm going to mention bounding boxes because they come up in PostGIS a lot. Every geometry has a bounding box, which is just 2 corners that describe, you know, minimally how much space it takes up. And you use those as a first cut on your queries. So a lot of your indices will work on those bounding boxes, not on the geometries themselves, to cull out all the things that aren't close to each other at all. So if you wanted to select all the points that are in, you know, California, you can, from a map of the United States, all the cities, you can take the bounding box of Atlanta, and you can see that it's not overlapping with the bounding box of California in a heartbeat, and not even go into it. And then the bounding boxes of things that overlap that are closer, like something in the western half of Nevada, then you have, like, you would do more work on those. So it's not really a data type, but it's important. There's a picture, there's a point, there's a line, there's a bounding box and a polygon. That's a bad drawing of Benton County. And that would actually be against it because that's the minimal distance here. The other thing to mention, I'm just going to mention it, is levels of detail and abstraction. Depending on how close you get to what you're looking at, changes how you model it. And first of all, you might model, for example, you might model a road with 5 points or with 500 points, depending on how much detail you want. And there is no, it's a fractal thing often, so there is no bottom. You just choose to stop adding points at some point. A road, I guess, probably has a bottom. A center line is defined by Caltrans or by ODOT, or whatever it is. But a coastline, how much space do you have for vertices? So the scale changes, and the lingo that geographers use is levels of abstraction for that thing, which is not how I was taught it, but there's the use of that word, but it works. So if you get more abstract, you have fewer details on the feature. And the map scale also changes how dimensions, not just detail, are used to model a feature. A short road could be modeled as a point in a map of North America, if it's a road that's 4 miles long. The map of Oregon, it'd probably be modeled as a line with no extent on either side. If it's a subdivision and you're doing the water and the dirt, you need to know exactly how wide that road is. Like, then it becomes a polygon. And there is no right or wrong to how you model a feature. In either of these cases, it's for whatever your application is. Questions? This is the Cook's tour of GIS, so here we go. Geographic and tabular data. Every geographic data set has basically two types of data associated. One is the description of geography. One is a piece of data, or a row of data that goes with that particular geography. So an outline of Portland might have the population, it might have the average elevation, it might have the area, et cetera, et cetera. And then a geography piece that gives you the exact outline. And in PostGIS, there's one row in, the reason this comes up is in the SRI products, a shapefile has a file for the shape, and then a DBF file with an ID that keys between them. So each shape, has an ID, and each row in the DBF file has an ID that matches the shape. And that's how you find out what the population is within a 100-mile radius of Portland is going between those. But it won't matter in PostgreSQL. It's good. Another concept you need to understand is to do analysis of any sort, you're going to work with layers that are, you're going to want to know things like a point within the city limits. So you need to have two data sets that sit on top of each other that allow you to make that query. So a different layer for each entity, whether it's counties or you want to know how long the roads are that cross through whatever. You need both the roads and you need a map, whatever. It's only possible to do this when you fix all your layers on the same base set of coordinates. And in the old days, they really did use Mylar and colored pencils to do analyses, and they color in with red, the population, and then color in the percentage white ethnicity, and and another, and then overlay them, and you get a new color because of the blending of the colors through the Mylar, and you could say, oh, well, that's a certain type of region. So,
Right. Hey, don't knock Mylar and colored pencils.
I wouldn't. Well, yeah, and for intuition, Mylar and colored pencils are, if you're trying to figure stuff out, you don't want to fire up your computer. Projections. Everything has a projection. Common coordinates for everything. They're complicated and boring at the same time. Read the slide.
Tell us how you really feel.
Especially important, vectors fix each vertex against its reference. Rasters fix two corners in the pixel size because then you can figure out where everything is, your math. Projection onto the sphere is different than projection onto a flat plane. Mostly geographers work with flat, at least small scale geographers work with flat plane projections, which add distortion. And then you'll see SRID, the acronym, bouncing around, and that's the spatial referencing system identifier. So that's how you determine what projection your piece of data is using, is that PostGIS keeps track of it through the SRID. Just in the butt. And then one thing, this is for the people that have non-geographic data sets that might want to add geography to them, which is a beautiful thing that PostGIS is great at. And you need to impute the geography of your non-geographic data set. So if you've got a zip code for your customers, you've got a mailing list. And as part of that, you've got a zip code. You can then impute where that person lives based on that zip code, assuming you're not going to geocode it, because that would mess up my example. And then, so you say, okay, that person is in this region that has a zip code named 95405. You don't know where they are exactly within that, but you can do a few things. You can take a random point and say, we're just going to pretend they're there. You can take the centroid of that area and say, we're going to pretend they're there, or whatever else. And then you can calculate things like, what's the average distance of my customers from some store, that you might open, or what have you. So this is kind of geared more toward demographers who have great data sets without geography, because you have to compute it somehow. And when you get a cancer registry item, it's not going to have the XY of where that person lived, but it might have their block, their census block, or it might have their census tract or whatever, and those are geographic things, so you can work backwards. Shape files and TIFFs. TIFFs are rasters, shape files are vectors. I'm not gonna. Other geostorage, there's all sorts of stuff out there. Kind of talked about it. There it is, it's on the slide. I'm running out.
Why is that not a question?
Huh?
Why is that not a question?
I know they have it, but I don't know anything about it. So history of DBs, this is for another presentation. There's only one open source DB that matters. And I'm not at the bigger meeting. History of GIS, this is almost half made up, but I mean, John Snow was the guy that did the maps of where the cholera cases were near the bad well in London, and Florence Nightingale actually did stuff, which is cool. Mylar and blood pencils. 1962, the Canadian government, something like the Canadian government, I don't know the exact details, started a big program. The SRI and what we know kind of took off and started in the 80s and were adopted by people with big budgets. The U.S. Army started GRAPS, which is a raster-based GIS in the 80s. In the 90s, you really see it take off. In the 2000s, you see it take off, plus the internet and Google Maps. And this is the date that the release candidate one for PostGIS was released. And it's at 131, I think, right now. Other important GIS projects. Map server is how I make my maps. All that other stuff is important. This will be on the slide. I mean, you'll run into all this stuff if you start doing open source GIS. You can Google it. Overview of PostGIS. I don't know their history. The way that PostGIS works is that you have your tables that are just the regular old tables you always have in a database, and you have columns that hold geographies. So we'll see that. You can have any number of columns that hold any number of geographies that you want. You delete them and you alter tables and add columns just however you're used to. And I'll just plug it and say that it's a really nice combination. You can go between thinking like a SQL programmer to thinking like a geographer and back and forth really nicely, which was not true of the SRI's so-called SQL thing, but I think it probably is true of Oracle, their deal, to give them credit. So installing Postgres, you install PostGIS on Post, what does that mean? So first of all, you need the Proj and Geos libraries, and you need to Google them so you know what they are. Then you just configure with a prefix, make install. This installs the libraries, does not install anything on the database. So none of your databases are as yet geographic. Important to know, in case you fire one up and you wonder why it doesn't work. So then you need to install the PostGIS libraries on a given database. This is how you do it. It'll be on the website. It's straightforward. But you need to do it in this order because there needs to be this. You need to have, however you say that, first.
PostgreSQL.
That's impressive. That's HVAC as all one word. So then you. This is in my machine. It's on PostGIS SVN/share. There's this, and that's basically their SQL file that sets it all up. And then you also in the same database. There should be a food GIS right there. Want to install the table of the spatial rep, basically the table of the SRIDs for all your projections, so that it can reference those when it does transformations.
Are there any .debs or RPMs that automate this stuff?
Maybe.
Okay.
Yes,
Okay.
except for the SQL portions. It'll install the libraries and all
Right.
that, but it's not going to by default create a GIS DB.
Gotcha, okay.
Yeah. It's never broken on me in my make installs. Never. So you want to make sure, it's for your own time, but you want to make sure you have Geos libraries and make sure you have the Proj libraries. Otherwise, it'll work, but it won't work right. And so when you do the LW PostGIS SQL file, they'll set up two tables, one of which is called geometry columns, which is a table of all the columns in other tables that hold geometry with some stuff, their projection and their vector data type, etc. And then spatial refsys, which will set up a table with all the projections possible and some proj command line text to transform one vector into another across different projections, which is nifty. Like I say, it's easy when everything's projected the right way. It's tricky when everything isn't, and that's really nice. You can also, it'll pollute your namespace with all sorts of things like as text and blah, blah, blah. And if you can fiddle with the PostGIS SQL file to set your search path and create schema and such to fight that, you can read that code. If you dump and recreate and you get weird errors, make sure you have your PLPG SQL set up. First, make sure you have your spatial refsys set up and then rebuild your database from your dump. Otherwise, you won't even know how to do a geography. There are the docs. There's littered throughout here. Great examples, actually, probably better than mine. 250 or 315. But so what's that? An overview and sort of use of functions, etc. So geometry data type. We will see this in a table. Let's see if I have a table. This is city limits from the state of Oregon. GID is some random thing that SRE puts in. The city name is, guess what, the city name. The FIPS code is the census code for that geography, which is very cool and another thing. Acres is numeric. I actually calculated it when I was learning how to use PostGIS for fun. The geom is the shape of the city limits. They are multi-geoms usually because cities are somewhat incorporated and somewhat not. So the city of Portland probably has unincorporated rings inside it, and so you can't do it with a simple geometry. The centroid geom is one I pre-calculated once, and that just takes the centroid of each geometry and stores it as a point. And it's an expensive operation, so I did I added the column and then I updated it to do it row by row based on this one. There's also so big blob. So the geom and centroid geom, it's just a lot of stuff. How exciting that is.
Wow. Hey, there's Waldo.
One is
Isn't that my DVD key?
one thing that is kind of cooler. This will be messy, but it will do as text. Oh. This is what happens, right?
As underscore text?
Or will be a column.
Yeah, you can't do it as text.
I don't really read things before I start typing, so. Select as text the geom from city. Oh. This is what you get.
Wow. That's a lot of text.
See, now that I've gone down.
Oh, it's undeveloped territory.
That's the idea.
Cool. So there's a point. There's another point. So use functions to access the geometry. Don't work with it directly. It's easy to convert if you actually read what you write and then press enter. So overview of the types of functions you will find in PostGIS. One is to return a Boolean based on a geometry or a couple of geometries. So oh, and these all have operators associated with them. I don't use them, so I don't know what they are. But, you know, there's a double @ sign with a minus will give you with it. So is geometry 1 within geometry 2? Is some point within the city limits of Portland? Yes or no? You can use it for joins, you can use it for whatever you want. Return a transformed scalar geometry. So take one geometry, return a transformation of it, 1 to 1. And my favorite example is the centroid. If you've got the outline of the state of Oregon and you want to find the average point, you know, where it would balance, like in all our physics or calculus 1 classes, calculus 2, whatever, where, like what point on which a plate made of homogeneous material, the shape of the state of Oregon, would balance. That's the centroid. Which is kind of, yeah, it's cool. And it's also useful if you're imputing geometries or, you know, it's also expensive. So if you're going to use the centroid of something, start a new column, you know, and then denormalize it and compute it for everything. Because if you compute the centroid, the state of Oregon on this computer, it'll take you a few seconds every time. Return aggregated geometry. So we'll see that in my examples very soon. So jam them together, take a geometric union. In my example later, we will take a geometric union of the 4 Portland Beach, the 4 counties, Clackamas, Multnomah, Washington, and Yamhill. We'll make one geometry out of them. It's nifty. You can do, you know, and you can also do intersections or differences, or we'll also take out a section of a county and then draw map with that. And then there are functions for geographic editing. So if you've got a line and you want to add a point to it, that's the line that's the big line you already have, that's the new point. You get a new line with that extra point on it, etc. That's cool. That's a rough kind of outline of the geographic functions. And I think they all, like every geographic function fits into that somehow. Then you have, PostGIS is kind of big, in case you haven't gotten that. Data validation. So you want to validate whether geometry is good or not, is valid. There's also a number of other, like is closed or number of rings inside it. Again, read the docs, but this will give you a way to start. The character of the geometry. So, but yeah, like number of points. It's not whether it's valid or not, but you might want to know how many vertices are in a given polygon or in a given road segment. This one is especially important because if you want to add to the end of the road segment, you want to know where the end of the road segment is and count a point so that you can put your point after that last one. This resets or returns the geometry with a new SRID. So obviously, all of these, if you want to update a given geometry column, you need to say set SRID, you know, update something, update table, blah, 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 set the geom equals set SRID, the geom, and then you'll replace your old one with it. We all knew that, but anyway. And administration, this adds a column to the geometry columns table that tells it where all the various pieces of geographic data are. It doesn't keep track of all your other data, but it has to keep track of your geographic data. This is a pain. It's also really important when it interfaces with other software. So if you want to use UDIG to display your map of Oregon, you need to keep all your geometry columns updated in that table. Because UDIG will go read that table to figure out what it can map from your database. And if it's not in there, it won't even know it's around, even though you can make geometry columns till you're blue in the face, unless you add them to the table with this function, which also creates some check constraints and stuff. You can't map anything. So. And geographic relate is really cool. It's the mathematical underpinning for all the Booleans. I don't understand it, but it's a matrix that describes how two shapes overlap or don't overlap. if you dig into it, that's where you want to go. Like if you're doing a within query and it doesn't work but you're like, it's within, damn it, why doesn't it say it's within? I know it's within. The real engine is relate. So, and I'll read about it at the same time you read about it. But it's easy to make a geography from a text. This is a slightly funky format. I don't know. Off the top of my head, I don't even know what it means. But this is something well-known text. So this is how you would get a geometry from this format of the geometry in text. And you can go, if you do this query, you get this. So it goes back and forth easily. The important thing is that this means you can type in coordinates in your little web application and it'll put them into geometries.
Yes. The supported topologies or whatnot, for the polygon, is that only supported as a kind of like the shape style polygon, or do they have some sort of arc node support too, like the grass at digit file?
So I mentioned polygons at the very end, or not polygons, topologies. As I understand it, they're basically the shapefiles. They do have multi-polygon support, and they do have multi-dimensional. So you can have a 3 or a 4, I think even a 4-dimensional. And I alluded to this, kind of the going away thing. And then there is a project to do the topology validation thing, and maybe you could explain it to me afterwards.
So basically,
but there's no sense of like one row interacting with another row's geography and keeping that straight.
Jason's.
But their structure kind of parallels the Esri shape files then. Okay. Yeah. Okay.
As I understand, and I don't know the structure very well, and I definitely don't know the binary format, so I don't know if that parallels it at all.
I have a question about this. Which is the latitude and which is the longitude?
I actually can't read that thing off the top of my head. I can do, if you do as text, you get something I can read, but this, and then I just didn't fix it. There you go. And yeah, but like with this one,
State plane.
it goes X, Y, so
So longitude, latitude.
I believe so. I believe it's X, Y.
Except those are projected coordinates.
Oh yeah, and those are feet. It's actually Albers, and they use, so the state of Oregon uses Albers, Oregon, which is a projection onto a plane of the state of Oregon. And so it gets invalid around the edges or something. It gets invalid.
Can you query on the basis of adjacency in PostgreSQL? Like, can you say selecting adjacent polygon? Or?
You can say, yeah. I mean, and if you have the vertices, yeah. Give me again if I don't answer it. I think in the examples, I can't remember what the function called is, but I don't think it's adjacent. Yeah, I mean, and if the vertices line up, then it just does that. And there's a certain tolerance.
So if you have good data.
If you have good data, you're fine. Yeah, there is no way to maintain topologies between rows other than by making sure there are no vertices that are kind of close. But slivers, I don't think there's a way to get slivers.
So it's more querying and analyzing the data. You're not going to try and build and clean the data with PostGIS.
You can do it manually, but there is no automatic. Indices, if I create an index, it's really important you do that for obvious reasons. So extended example. So now I'm going to flip back and forth between this and the other piece of code, which is my running of some stuff I wrote Thursday. It all works when you download my famous CD. You can run the SQL file. If you have the exact same setup as I do, it'll work. So the way you would import a shapefile, which is important because you will typically download a shapefile from wherever you download it. There's this function which comes with PostgreSQL, shape to PGSQL. Read about those at home. It generates a SQL file that you then open an Emacs or whatever and read. This, you put it into your database that you have set up already, because otherwise you just get errors. And if it's in a different projection than the geographies you already have in your database, that's a different issue. It's easy to fix it once you know how. It's a pain, but it's doable. So we're not going to do that. We all know SQL, I hope. So the overview of my example is that I'm going to do in 4 minutes. I have 4 tables. I have place names, which is the coolest thing in the world. The USGS keeps a massive file of place names, or the gazetteer of the United States, and it has just points that are worthy of a name. So airports and like old churches, like the old churches in a town will have a name in this, and that's cool. I will use the airports from it just as my example. My code on the CD is that, and we're going to toggle and look at it. I'm pointing at the screen, as if you can see. We're going to toggle and look at that, and that's how you get it. So there's Oregon. I generated these maps with Map Server. Using these commands, they will be online. And I'm going to close it in. So there's Oregon generated from a highway file and a county file. Here are Oregon airports. The labeling is all screwy because it's map script and I don't really know how to use it. But those are basically everything that has an airport designation in the USGS place names file. So there are a boatload of them because every hospital of any size at all has a heliport, and they make it in there.
So that doesn't necessarily mean you could land a plane that has to roll out. It just means there's a...
Yeah, and it means that the board of whoever at the feds decided it was worthy of a name of an airport.
Well, I mean, even Cascade Locks has an airport.
You might have 2.
Yeah.
I mean, because if Joe
It's
Blow
a
has-
farmer's field with a road.
Right. No, but if that road, I mean, I think if the FCC or FAA, if they keep track of it, it's in there, and they keep track of a lot of stuff. You know, that you and your 2-cylinder lawnmower attached to a wing. So we're going to select all the airports and their containing cities. We're going to do this query, and we're going to leave out all the airports that aren't within city limits. And I'm going to show you that. And there we go. Select B city name, A name, desig. That's the column in the place names table that gives you whether it's an airport or a dam or whatever it is. It's a way pool file. You just look at everything. Place names, that's the table with the place names. City limits, that's the table with the city limits. So, and then this is our geographic query. So where the geometry of place names thing is within the geometry of the city limits. We want it in order by city name. I don't know if I guess Cascade Locks is not incorporated. Is that true?
No, it is incorporated.
I guess it's, okay. It
It's
doesn't
just
have
that
an
nobody
airport
actually
within
wants to know it exists.
You change the signs on the one, point in the wrong direction. So these are cities that have airports within them. And the name of the airport and the designation airport is redundant, but so you can see McMinnville has one. Medford has a lot, 3. Plus whatever's nearby and not in the city limits. So it goes on. It's just data. Oops. This is example 2. Select the count of airports by city limit where there are more than 2 within the city limit. There's a query, and what queries look like. There's one piece of data, Portland has 17 things that are called airports within the city limits. Here I use the thing that I can't believe is not part of the main package, array accumulation, whatever. Just because it's nice, you get to see them all at once. And it goes on. Select all airports within 10 miles of Portland. So I'm putting these into tables.
Why OIDs?
Oh, because map server craps out if you don't have one because it's, you know, circa 1985. Because to make map server happy.
Okay. I think actually that has been removed in the newest
think it's
server that
5.0.
just released.
Yeah, I'm using 4.10 because I didn't want to build it for this. Yeah, so that's map server, and I know so little about map server, it's not even funny. So there's probably a better way, like you say. So we create these tables. There we add a geometry column for that table. And we're going to insert into that table all of these. And that's a select statement. We know what they look like. And that's the binary geometry in it, and with all the stuff you expect from the subset. And then here they are mapped. And someone should count them to make sure there's 24, but it won't be me. 3 of them have names because I don't know how to use map script. So I'm now over time.
Okay.
Should I run, can I have 5 minutes?
Yeah, we can probably do 5 minutes.
So select cities based on their area. Select some cities based on area more than 1 mile. You have to divide your feet by, you know, square feet. And then we're going to do it like that. So according to this map, Portland has 145 square miles in it. Salem, close second, 47, etc. Select neighboring counties, the 4 PDX. Okay, well, it's not a grammar presentation, so, but select the 4 counties, select counties that border the 4 central PDX counties is what I was thinking when I wrote that. So these are all just cities and their square miles. So select distinct. There's probably a better way to do this. The county name from counties A, counties B, where basically our start counties are going to be the 4 that we all know about, and then ST touches. That's what I'm going to touch. And I don't know the details. I'm sure there's some tolerance, so if they're off by a foot, I bet. I don't know.
Topological thing is good for that kind of.
Yeah, and there's a topology project within the PostGIS thing. I find it incomprehensible based on their docs, and I don't know enough to put it together between them. So we just did that, right? So, okay, so I'm going to do one more example, then I'm going to go to the end. So this is a geometric union of the 4 PDX counties. So we want to get one shape where there used to be 4 shapes, from 4 shapes. So we do all our making tables, then we insert into collected counties the geom from geom union. So this is an aggregate. Yeah, that's an aggregate on these 4 county geometries shown there. I don't know why that's simple, but it's still, you get the idea. And so basically we just get 1 row out of 4. It's an aggregate. And there it is, it maps actually. Then I have some other stuff. So one of the things, so these when it says example 7, that means in the code it says example 7 as well. You can look it up. I don't have time, so I'm going to go over them too quick. I took a bunch of points, then using PostGIS functions, drew one big line. It's basically 10 airports chosen at random from across the county, ordered by Y value. And then I made a road out of it. You know, it's some bullshit example, but but you can see. So if you have a bus that's sending its coordinates home point by point, you can make a line out of it as that bus goes wherever it goes.
So somebody didn't solve the traveling sales problem there?
No, that's not the quickest way to go around Oregon. I don't know why.
Most entertaining, but not quick.
And randomized too, so you never know. But here I made a polygon from the edges of these points. A convex hull. I made a polygon from the convex hull of those points, and then subtracted that polygon from the bigger multnomah polygon. And this is the remaining. This is most of the remaining multnomah polygon. And there's a little bit of multnomah right there that's not part of that convex hull. It does a set difference on it. So, fun with highways. I have some stuff in there. We basically, so denormalize. You have to denormalize if you have a lot of processing, because this is expensive. Displaying data. These are the various ways you might display data. I use map server with above data, then there are other things. Closing thoughts. So, as far as really cool Postgres applications go, I think PostGIS has beat out T-Search because one can read about PostGIS and understand how to use it.
Hey, T-Search is integrated now.
Now T-Search should be the same, and but they're equally cool and just really cool for us to have these things. So this is a plug. PDF's plug should do how to use T-Search well as an evening. And I will drive up from you for that.
All right, you're on.
I won't give it, but further reading, random links. I mean, they're all great, but start with PostGIS and go on from there. Oh, there's one woman who answers all the questions on the PostGIS list that probably should be in here. Her name is Regina Obi, and you know, at 2 a.m. you have a question. How do I do a union of whatever? 2:30, she sends you back. So further GIS, or further considerations. Useful, obviously, for web-based GIS. You can see how you can go from text into geometry and back again. Very useful. Digitizing and editing, I have not covered at all, but one needs to do this. One needs to take a map and draw vectors on top of it, and then store that as a geometry into your database. You need to use like UDIG or SRI programs or something to do that. That's a visual operation, and there's no real way around it. Geocoding, take an address, find a point, find a geographic point. There is a Tiger project as part of PostGIS to do that. It's just something that happens. You know, it's an important thing that you need to feed in with this thing. So, routing and networks. I didn't cover routing and networks at all. There are two projects in PostGIS. There's PG Dijkstra and something else, PG Routing, I think, that are tempting. So you can just ask for the traveling skeleton up. It'll give you the best one sometime. But you can't tell when. Topology. Now, as I understand it, topology is to make sure that it logically all fits together. All your various pieces fit together with each other. There's a topology project at PostGIS that's making progress, whatever gets there. Long transactions. PostGIS does have support for long transactions, and you need them if you're doing long editing between, if two people are working on the same editing project with their computers, adding dots and connecting things with lines. You need long transactions to coordinate them. I don't know anything about them, but I know it has them. And for some of the Java libraries, we need to have them. I'm going to do a presentation on this at the Population Association of America in March. I'm going to show demographers how to do linear regression and with geographic data. I hereby offer myself to give probably better, more grammatical version of this to anybody that wants in the future. Yeah. So there's further considerations. Let me see. And creative possibilities, and I'm going to end on this. So you see how you can geographically enable databases you already have, like mailing lists, streaming GPS data, can use it with triggers to build, the routes of the bus or what have you. Google Map mashups. If I had more time in my life, I would write that. Python class with table name inputs, inheriting from a cheated template to make the JavaScript that would make it all happen. It'd be great. You just put in a table and you get them out. Others, we don't have time for discussion. That's it.
Are there any projects underway to provide, sort of graphical front-end support for PostGIS?
Emphatically not PostGIS, because there might be admin.
There's a PHP JS admin floating out there. I don't know how well it works, but
That
PHP WebSQL for those.
Yeah.
But that's just
We can tell by his response, he's excited about that.
So the thing about geography is, like I was saying, with editing and digitizing, you need that. You need a visual thing.
right.
And so that you would usually plug into something else. Refractions also makes you dig. And I wonder if there's anybody that works for refractions here? Okay. And that has some editing capabilities and such. As far as adminning, no. Not that I know of, and I don't think anybody's making any noise to do it. But there's a lot of work done to interface PostGIS geographies with visual programs and manipulate geography, because that's so important.
freegis.org. They have a really good listing, and they keep tight watch on the grass list, which is now run out of, by Berkeley, out of Italy. And they have some nice graphical front ends for geographic information.
Yeah.
They'll tie into any kind of backend that you want.
OSGeo has some selected projects as well.
What does?
OSGeo.org.
Yeah.
There's a lot of work to display geographies. Huge amount. I think QDig and QGIS are the two biggest, and OpenEP.
So while Webb's cleaning up and Dave's coming in,